How does clustering work in unsupervised learning? In today's fast-paced world of technology, understanding how clustering functions in unsupervised learning is more relevant than ever. As artificial intelligence continues to evolve, many individuals are curious about how these systems can analyze and organize data. Just yesterday, a new report highlighted the growing use of clustering techniques in various industries. So, what exactly is clustering, and how does it work? Clustering is a method used in unsupervised learning, which is a segment of machine learning where the data lacks labels. The primary aim is to find natural groupings or patterns within the dataset without any predefined categories. The essence of clustering lies in grouping data points so that those within the same cluster share more similarities than those in different clusters. The process begins with feature representation. Each data point is described by a set of features or attributes. These features help define what makes each data point unique. Next comes similarity measurement. A metric is chosen to assess how alike or different the data points are. Commonly used distance measures include Euclidean distance. Once the similarity is established, clustering algorithms are applied to organize the data. One popular method is k-means clustering. This algorithm divides the data into a specified number of clusters. It starts by initializing cluster centers and assigns each data point to the nearest center. The centers are then recalculated based on the assigned points, repeating this process until the clusters stabilize. Another method is hierarchical clustering. This technique creates a tree-like structure of clusters. It can either merge smaller clusters into larger ones or split larger clusters into smaller ones. This approach allows for a hierarchy of clusters to be formed. Evaluating clusters can be challenging since there are no labels to guide the process. Metrics that assess the compactness and separation of clusters are used for evaluation. Examples include silhouette scores and within cluster sum of squares. Clustering has numerous applications across various fields. It is commonly used in market segmentation, image analysis, healthcare data grouping, and customer behavior analysis. By organizing data effectively, clustering aids in better decision-making and pattern recognition. As artificial intelligence tools like Chat Generative Pre-trained Transformer, DALL-E, and Midjourney become increasingly popular, clustering plays a vital role. It helps organize large datasets and outputs, improving content recommendations and productivity plugins. For instance, clustering can categorize generated images or text outputs, making user interactions more efficient. However, ethical considerations are essential when applying clustering algorithms. If the data reflects societal biases, the resulting groups may perpetuate unfair treatment or discrimination. Transparency in the formation and use of clusters is crucial, especially in sensitive areas such as hiring or lending. Clustering in unsupervised learning organizes unlabeled data into meaningful groups by measuring similarity and applying algorithms like k-means or hierarchical clustering. Its applications are extensive, and ethical considerations must be taken into account to ensure fair use in artificial intelligence systems.